Both of these scales are fractional inch scales. The one on the top is divided into 1/16 of an inch, and it's labeled 16. The one on the bottom is divided into 32nds of an inch, and it's labeled with the fraction 1/32. You'll see on different scales, sometimes they'll list just the bottom number, and sometimes they will list it as a fraction. Now what does that mean? That means that this scale, if we counted each one of these spaces, that there would be 16 spaces in this inch. On the other scale, if we counted all of those spaces, there would be 32 of them. Now you still have your regular fractions that you're used to, such as 1/8 of an inch, which would be this line, 1/4 of an inch, which would be this line, and 1/2 of an inch, which would be this line. Now both scales have those, and so let's take a little practice and measure a couple of lines to see why we would want both scales. Let's remove this one for a minute. And let's take a measurement with our 1/16 of an inch fractional scale. As we slide that up there, what is that measure? Here's an inch. Here's an inch and a fourth. Here's an inch and a half. So our measurement would be 1 1/2. Now if we tried to measure the line above with this same scale, you'll notice that on this end our measurement falls about halfway between these two lines. So it would be hard to get an accurate measurement with this scale in this case because it doesn't fall on one of the regular increments. Let's try it with the 32nd of an inch scale. Now we can still measure that line, and it still ends up at 1 1/2 inches on the bottom line. But notice what happens when we get up here to the top line. Now we have a mark that lines up with the end of our line. What is that mark? Well, you notice that it's the shortest line on the scale, and there's a whole bunch of those little short lines. Well, these short lines represent the 32nds of an inch. Now, the easiest way to figure out what that mark is if you will count these lines that are the same length using odd numbers, we can figure out what that is. So let's try it. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25. That line measures 25 32nds of an inch. It works every time. The reason that we don't count the other lines is because even though these are also 32nds of an inch, because they're even numbers, they can be reduced and we call them by a different name. So even though this line is 2 32nds of an inch, we can reduce 2 32nds by dividing the top and the bottom of the fraction by 2, and it would reduce to 1/16. So instead of calling this line 2 32nds, we actually call it 1/16. The same with this line. Even though this is 4 32nds, it can be reduced by dividing the top and bottom by 4, and we call this line 1/8. And so the easiest way to figure these out is once again to count them with odd numbers. Now the same thing would work with the next biggest line. If we had a line that fell on one of the 16ths of an inch, then we could count those with odd numbers as well, as long as we count the line lengths that are identical in length. So this would be 1, 3, 5, 7, 9, 11, 13, 15. So if we were trying to measure this point right here, it would be 15/16. And so that's the easiest way to figure it out, is to count with odd numbers the lines that are the same length. And it would work for the eighths, it would work for the fourths, it works on any of them.